going to talk about 10 gigabit Ethernet. It's pretty obvious. Just a couple things about the market, and then short dig down into the technology. It's pretty straightforward, and pretty straightforward, a high-level overview. Again, questions at the end. So I think the 10 gigabit Ethernet concept is pretty well understood. Basically, it's yet another iteration of the 10 to 100 to gigabit, now 10 gigabit Ethernet. And so the technology is being positioned primarily in the same applications as other existing Ethernet technologies, with one twist. Whereas some of the other Ethernet technologies have been at least nominally proposed for wide area or metropolitan area applications, 10 gigabit Ethernet has an explicit PHY level to run the SONET and be used in a wide area network context. I'll talk about that a little bit more. So here's just some quick overview of applications. Again, nothing too mysterious here. Basically, it's an interconnect layer between, or an interconnect technology between routers and switches within a POP. Same place you'd use Gigabit Ethernet, packet over SONET, or ATM today. For peering, as we move up our peering to another notch up in speed, either at public peering, so routers interconnecting with an interconnect peering switch, or as a private peering link between co-located routers. In data centers, again, for connecting either switches, which in turn connect to high-speed servers, or eventually, I don't think there are any host NICs yet at 10 gigabit Ethernet, although they're certainly purported and on their way. So see direct connect of high-speed host to the router or high-speed switch at 10 gig E. And then again, finally, as I noted, technology that's specifically designed to run over a SONET or SDH physical layer in a wide area or metropolitan area environment. So how does 10 gig E relate to Gigabit Ethernet and the other Ethernet technologies? It's the same 802.3 MAC layer and the same frame format. Again, just running at a higher speed, so same standard packet sizes and such, or frame sizes. The one thing that's been happening primarily in the Gigabit Ethernet space is the use of jumbo frames. It's not included in the Gigabit Ethernet standard, and the same has been carried forward in the 802.3. That is, there's again no support for jumbo frames, but we expect that various vendors will support that, but just not part of the standard. So kind of the same as Gigabit Ethernet in that regard. A difference between Gigabit Ethernet and the other Ethernets and 10 gigabit Ethernet is there's no support for half duplex mode, so no kind of really a LAN mode. It's really a point-to-point framing technology in between two devices. And whereas that may not have been, say, in Gigabit Ethernet, that's not that widely used anyway, the half duplex mode. In 10 gigabit Ethernet, it doesn't exist at all. And so, in conjunction with that, CSMA CD, since it's a full duplex, really it's kind of two fibers sending back and forth to each other. There's no need, kind of no collisions kind of don't exist, so you don't need CSMA CD. And some of the other Ethernet and MAC technologies like .1Q and .3AD for various other kind of how to make Ethernet more useful in different applications. Those carry straightforward from the other Ethernet technologies right to 10 gigabit Ethernet. And also, given that this 10 gigabits, there's no copper support in 10 gig E in the standard. So something else I mentioned is a LAN PHY. So that's actually runs at a 10 gigabit per second. And then there's also a WAN PHY. That's where we take some of the bandwidth and use it for the SONET or SDH framing. So the actual WAN PHY runs a bit slower at 9.229 gigabits per second. Again, I'll talk about that a little bit more. So some of this is just kind of tutorial information, so I'm not going to read all this to you and just put it on the slides so you have it as a reference. And so PHY and PMD, I'll go to an architecture slide that talks about some of these things. So PHY and PMD are the physical layer and physical media dependent layer within the 10 gigabit Ethernet architecture. WIS is WAN interface sublayer. That's something you may see as a feature that would or would not be supported within a particular interface, for example. And this is basically the adaptation sublayer to allow that difference in clocking speed that I mentioned between the LAN and WAN PHY. WWDM is yet another WDM flavor, and that's specific to one of the kinds of PHYs. Again, I'll point that out on one of the other charts. And then these last three, the XGMII, XAUI, are inter-chip interfaces. Basically, those are we're providing standard interfaces between the optics and chips, and within the chips within an interface to provide mechanisms for standardization of components, and so the people building the interfaces can use a variety of off-the-shelf components in different combinations. And Zenpack is a particular consortium designed or developed an agreement for optical to electrical conversion. So that's actually a component, an off-the-shelf component for the optical to electrical conversion. Again, intent to have a standard mechanism for doing that, drive down component prices, and make interfaces less expensive. There are 7 different media types, or PMDs. They're listed out here. I'm not going to go through them all in detail, but basically they just map into the different multi-mode and single-mode fiber types, and also across different distance requirements, short reach, intermediate reach, long reach, etc. And then finally the last one, and that's the WWDM that I listed on the last slide. And this is kind of a way to do multiplexing of wavelengths onto the fiber pair. It's a little different than CWDM or other DWDM, the way it's done. So, but again, don't have a lot of time, so I won't go into the details. So this shows graphically some of the stuff I've been talking about. So, like all 802.3s, we have a MAC layer interfacing, so that's what IP would run over. Then in the middle shows the XGMII or XAUI. Those are the chip interfaces, and then the different PHY types, the LAN PHY, WAN PHY. Within the LAN PHY, there are the 2 different flavors. One with the 4 serial or the 4 fiber interface WWDM, and then the standard serial LAN, which is the pair of fibers. In the case of the serial LAN, there are 3 different physical, the media dependent. So that's the 3 different wavelengths and the different distance requirements, and then their correspondence is corresponding for the WAN PHY, but with the WAN interface sublayer framing overhead for SONET adaptation. In terms of the status of the standard, things are actually pretty close. As a matter of fact, they're about as close as they could be without actually being standardized, at least unless something happens this week. So this has been happening in the 802.3 AE working group. The work started in 1999. Within IEEE, there's a concept called a project, and that allows the work to formally occur within IEEE. So that project started in January of 2002, or January of 2000, so about 2.5 years ago. There's a status. I'm not going to go through all the gory details of IEEE standardization process. They all vary different. It's different from IETF. I'll leave it at that. And there's a web page there that points to where you can see how that all works. But basically, it's a sponsor ballot status now. Draft 4.3 is the current version, and I would say this is probably not strong enough language, but significant changes are unlikely at this point. Even minor changes are pretty unlikely at this point. The final ratification of the standard is supposed to happen this week in one of the other IEEE meetings. So as long as that happens, then it takes a couple more months for them to do some more editorial cleanup and things like that, at least potentially, and then actually issue the standard. But basically, it's done. From an interoperability perspective, at Interop in May, so a month or so ago, they had one of the regular interop test demo kind of things. So in the actual equipment demo, their press release said something like 24 vendors or 24 participants or something like that. But if you read it more closely, some of that was equipment vendors, some of it was chip vendors, talking about the different kinds of chip interoperability and things like that. But anyway, a bunch of different equipment was connected together at Interop in May. And there's, again, the press release, the web page is there, so you can kind of check that out and see what the exact status was. So just to wrap things up, it's pretty viable, at least from a Juniper perspective, we think so. The standard is basically complete. Products are shipping, including switch interfaces, router interfaces, test equipment, the appropriate cables, kind of all the pieces that you need to deploy 10 gig E are pretty much ready. And with any technology, of course, this is new, however, so there will probably be at least a little bit of ongoing potholes in the road. So make sure you check for interoperability and things like that before you go too overboard. There's some interoperability testing happening at the University of New Hampshire Interoperability Lab, and of course Interop. The Interop test results, of course, are trade show interoperability results. So take those with a grain of salt. You know, those are done with all the carefully crafted smoke and mirrors and all that stuff. But the UNH test results are usually pretty solid. And of course, products are still just coming on the market now, so you need to test for maturity in that regard also. Excuse me. So there may be products that are just evolution of other, Gigabit Ethernet products and things like that. So check for performance as you are doing your product selection in this space. This last slide just shows a bunch of reference websites. The IEEE website, 10GEA is the 10 Gigabit Ethernet Alliance. And so that's both some market materials, some white papers and things like that provide technology overview. Ethermanage.com is Charles Spurgeon's website from the University of Texas. Lots of really good information about Ethernet in general, 10 gig and others. This next one is the University of New Hampshire Interoperability Lab. And they've been doing a pretty good job at putting up a lot more tutorial information on that webpage, including some fairly technical tutorials about the details of 10 gig E. There's the ZenPack webpage that talks about that component. And then there was a workshop at the San Diego Supercomputer Center on deployment of 10 gigabit Ethernet. I guess it was last fall or something. And again, so a bunch of presentations are there that provide some perspective on the use of 10 gig E, including 10 gig E in the WAN and how it might fit. So I guess that is all I have. I think I went through fast enough to bring us in time for lunch. And we have Mr. Bill Woodcock walking up to the microphone for a question.
Want to do a little bit of prognostication?
Do I want to?
Yeah.
Sure, whatever.
Okay.
Depends.
So,
I mean, I'm
copper. You say not in standard. So
right.
Is this going to be sort of like Gigi was, where, a year, 2 years from now, the problems of physics will be overcome by force of money, and we'll have, meter, 2 meter, 3 meter copper interconnects?
Yeah, that's a pretty good question. I think it actually relates to some of the other, to another question which I thought was what you may have asked. So I'll answer your question and the other question in anticipation, which is basically cost, right? One of the motivations for doing something like that would be cost for the interfaces themselves, and presumably, I guess fiber's not that much more expensive than copper these days, but at least the interfaces would presumably be cheaper. So, will it happen? I don't know. I'm not a physics guy. Is it possible? I'm not going to deny that it's possible. I think it's certainly within the realm of possibility. I mean, we build interconnects inside the routers and stuff like that certainly run at those kinds of speeds. So, the question is, could we really build it cheaper? If we look at an interface, the costs are in there's a bunch of pieces in the cost, and this kind of relates to the other question, right? There's buffering, there's some kind of forwarding engine, or at least some mechanism for taking the frames off the physical media and then sending them into the switch fabric, et cetera. Yeah, go ahead.
For those in the audience who don't know, could you give people some idea of what the cost of an interface is right now?
Wow. That's a good question. That's a good question. You know, we just announced ours, and I really have no idea what it costs. I'm not a sales guy, or any Juniper people, or anybody else in the audience from any vendors who could provide some insight. I just don't know. At least I know ours are at least not dramatically less expensive than the 10 gigabit SONET interfaces. It's not the kind of order of magnitude difference that people were anticipating, or at least some were promoting that, you know, Ethernet's going to be so vastly cheaper than SONET that you'll get it for free relative. And that's kind of where I was going. Basically, if you look at an interface cost, a lot of the pieces are all the same. The optics are the same. The framers are slightly different, but close, especially if you're using the WAN 5 for 10 gigabit Ethernet, and then you need to put buffering on the interface and all the other stuff, right? So it kind of is a wash from our perspective in terms of component costs. Yeah.
There's a perception that in producing the standard, they've screwed up, and that there's essentially a LAN version and a WAN version. The advantage of gigabit Ethernet was that the chips were produced in mass quantity and therefore were cheap. So by having two versions, one which is applicable to the LAN, if that one is mass produced and the other one isn't, then it doesn't have the advantage of being cheap. And since they only put the error detection in the one that's not cheap, then there's no incentive to not just use SONET.
Right, right. Well, actually, a couple of comments on that. I think you're right on track. And it's really, in this case, the optics are becoming the dominant piece, and it's, again, kind of the same, right? And if you start using WAN 5s, then about the only thing you do is you get a little more overhead for SONET framing and the error correction. One of the other things which I didn't put in the presentation, because is there is some error, well, I guess it's better characterized as fault monitoring and link monitoring in 10 gig E at a link level, which is new also. So it's kind of a little better than the other Ethernet technologies in that regard. So, yeah.
Just wondering if we could do a show of hands of people interested in deploying the 10 gig interfaces in the short term.
10 gigabit Ethernet?
Yeah.
Sure. Whatever. So if you're interested in deploying 10 gigabit Ethernet interfaces in the short term, being calendar year 2002, say, raise your hand. Was that helpful? Okay. Yeah. Okay. And I guess I don't see any other questions, so thanks very much.